Elon Musk has a new question for the chip industry. Can one of the largest semiconductor operations in history be up and running in less than 3 years? His answer, or at least his bet, is yes. His newly announced Terafab project has teams racing to lock in chip making equipment, offering suppliers extra cash to give Terafab priority, with the goal of having limited production by 2029. Analysts who've run the numbers say that at full ambition, this thing could cost between 5 and $13 trillion, price tag that would make it one of the world's most expensive industrial undertakings ever completed. Welcome to Business Insights Daily. I'm your host Sashank. What does a multi-trillion-dollar factory actually buy? As we go, keep this in the back of your mind. If you spend more than the GDP of most countries building chip capacity, what are you really trying to buy? Safety, dominance, or just the right to move faster than everyone else? Terafab is Musk's umbrella project to manufacture advanced chips for Tesla, SpaceX, and its AI company xAI. Chips for self-driving, robots, data centers, and space systems. Flagship site is planned for Austin, Texas, but he wants to build an advanced technology fab that, in his words, has all the equipment needed to make chips of any kind and test them on site. So far, the concrete plan is more modest than the trillion-dollar headlines. The initial capital is roughly 20 to $25 billion for the first phase, described as a pilot phase. The target is a pilot line able to process about 3,000 wafers per month, with first silicon out, actual chip production by 2029. And the scope is to start small in Austin, then potentially scale into a mega site with multiple sites if everything works out. Behind the scenes, Musk's team has been blasting urgent requests to equipment makers, Applied Materials, Tokyo Electron, Lam Research, and others, asking for lightning fast price quotes and delivery timelines, sometimes over holiday weekends, and explicitly saying Terafab will pay significantly above list prices if suppliers move it to the front of the line. Can money bend the laws of chip physics or just the queue? Which leads to a second question. If you offer to overpay every supplier in sight, does that actually compress a decade long industrial ramp into a few years? Do you end up with bidding up everyone's costs in a system that still has hard limits? They're not Musk numbers, they're analyst estimates of what it would take to get anywhere close to his stated long term goal, manufacturing enough AI and logic chips to support roughly 1 terawatt of computing capacity per year, far beyond today's global output. Bernstein and other analysts have walked through the math. A modern leading edge logic fab capable of say 2 nanometer class chips typically costs 25 to $35 billion and produces around 20,000 wafers per month. If it marks the 1 terabyte compute target, you need the order of 140 to 360 such fabs, depending on yields and mix, everything from GPUs and CPUs to memory and advanced packaging. Just the logic fabs alone could run $3 to $4 trillion. Once you add memory fabs, advanced plant packaging, and everything else, plus some cushion for yields and delays, you land in the 5 to $13 trillion range. For context, it's more than 70% of the current market value of all publicly listed chip companies combined, by some estimate, on the order of a single year of the entire US federal budget. No one thinks Terafab is writing $5 trillion check tomorrow. The point is, if you take Musk's most ambitious statements literally and scale them out, the implied build out is staggeringly large. Who Musk is pulling in? Intel and others. Intel, in twist, has said it will join the Terafab effort to help refactor fab technology and collaborating on process development for chips designed for Tesla, SpaceX, and xAI. For Intel, This is a way to get closer to voracious AI customers and showcase its foundry ambition as it tries to claw back relevance in leading edge manufacturing. At the same time, Musk's team is negotiating with Samsung, who reportedly prefers to dedicate capacity for Tesla in its new Taylor, Texas fab rather than fully backing an independent Terafab site. But there's potential cooperation around advanced process technology. There's also the existing reliance on TSMC, Micron, and others, whom Musk has publicly praised but also framed as too slow to expand to meet the demand he foresees. So, Terafab sits in an unusual place, part in-house project, part partnership hub, part partnership in the broader ecosystem of TSMC, Nvidia, and the incumbents. Is this a fab or a negotiating tactic for the entire chip industry? Which sets up a third big question. Is Terafab mainly a real attempt to build a new manufacturing empire, or is it also a way to scare current suppliers into moving faster and giving Musk better terms if he's willing to go around them? Why Musk wants his own chip? Underneath the theatrics, there's also a strategic rationale that's not hard to understand. Musk's companies face the same constraint everyone in AI and advanced computing does: access to those cutting edge chips. Nvidia's GPUs are oversubscribed. TSMC's leading edge capacity is booked years out. Every frontier AI project is competing for the same wafers. For Tesla, autonomy, robotics, and in-car AI depend on high performance, low power chips tailored to its software stack. SpaceX, Starlink ground stations, satellites, and potential in orbit compute all need specialized silicon. And for XAI, training and serving large models at scale requires vast GPU or accelerator class compute with costs measuring in billions. If you believe the demand curves Musk is projecting, then his companies alone will need an enormous fraction of global AI compute. Then relying solely on external suppliers looks risky. A dedicated fab or a network of fabs is an attempt to secure that supply and control cost trajectories. The question is whether the speed, capital, and know how required to make this act visionary vertical integration are something closer to the kind of overreach that has been tripped up many ambitious industrial projects in the past. The feasibility and the risks. Semiconductor people, to put mildly skeptical. Getting an advanced fab from groundbreaking to meaningful volume usually takes 4 to 7 years, even for experienced players. Musk is talking about limited production by 2029, with a standing start in 2026. Aggressive even for a modest pilot, let alone a template for global builder. Building and running leading edge fabs requires armies of highly specialized engineers and technicians. Global talent is already tight. TSMC, Intel, Samsung, and others competing for the same people. And even on the lower, only tens of billions of dollars scale, Terafab will intersect with government subsidies, export controls, and geopolitics. The multi-trillion dollar scale implied by Musk's long-term rhetoric, it would be an economic project on par with national reindustrialization efforts. And then there's Musk's own track record. He's repeatedly set wild, ambitious timelines for rockets, cars, tunnels that then take longer to get there, sometimes much longer. SpaceX and Tesla did ultimately deliver breakthroughs, but rarely on the schedule in the original tweet. So, Terafab may well be real, in the sense that a pilot fab in Austin is very likely to get built and to ship some chips. The open question is whether the broader vision, hundreds of fabs, trillions in capex, 1 terawatt of compute, stays an aspiration, becomes a multi decade grind, or gets scaled back as reality sets in. So, The next time you hear about the shortage of AI chips or see headlines about new fabs breaking ground, it might be worth remembering that somewhere in Austin, there's a team sending out frantic emails to equipment makers, trying to turn one person's vision of light speed chip making into actual silicon. In the process, testing how much one project can bend one of the most complex industries humans have ever built. Stay informed, stay ahead, and we'll see you tomorrow. Thank you for listening.